Okay, so in this video we're going to go over Work Energy Theorem. This is a follow-up video from the previous video that we have done on work, power and energy. Of course, we promised to say we are going to bring an overview for us to understand how work and energy are related. Okay, do we need work to do energy, or maybe do we need energy to do work? The other way around. Okay, so I want to understand how these two are related. Right, so we know to say for work is just a product of what? It's just a product of force multiplied by what? By distance. And another thing that you need to keep in mind is that for work, it's very important that you also keep in mind that work is not only, let's say you have a horizontal surface here, and let's say you have a block. Then let's say you're applying a force going in that direction. We are doing work, and it's not always that it's applying like the force is acting parallel to the surface on which the object is resting. Sometimes, let's say you are pulling this object at a certain angle like this one. Okay, so meaning you have this part, you have the theta there. So it's like you have a force here. Of course, you want to go in this direction. Of course, when you are pulling this object, it's not going to go like up, going in this direction. It's going to go where? In that direction. Hence, we need to take into consideration the what? The angle that we have. Hence, since this is in the x direction, we know to say when it comes to the x direction, we use what? We use cos, and this is just from the. This is just from this. Let's say we have this. Okay, so we know to say this is our y-axis and this is our what? This is our x-axis. That's our x-axis there. Okay, so it's like we know to say us going in this direction, and you gain more understanding when you start if you have done vectors in physics, of course. So we know to say when you're talking about movement in the x direction, it always has to do with what? Cos. In the y, we deal with what? With sine. But in this case, we're just going to choose what? Cos theta right there. Okay, so us seeing this in this manner is going to help us a lot, because if let's say we are pushing in going in the other in this direction, the force is being applied parallel to the what? Parallel to the horizontal surface, which is horizontal, meaning the work is being done because the force is going in this direction and the distance is also going where? In that direction, meaning work is being done. Okay, so if we say cos theta, what's the angle here? So you know to say these are going in the same direction. So what will happen is that we are saying the cos is going to be what? 0. And when you go to your calculator, cos 0 is the same as what? Is same as 1. So it's more like you are multiplying what you have here, the force multiplied by the distance, by what? By 1. It still remains the same thing. So if we see it in that manner, it's really going to help us, because when it comes to, let's say you're pulling, like using a certain tension, you have an angle, and if we see it in this format, it's going to be very easy for us. Okay, so now let's get to understand how work and energy are related to each other, and how for work to be done, we need energy. Okay, so now here is the final formula that we are going to get. The work done is more like is equals to the change in what? Change in energy. Change in kinetic energy. Okay, change in the kinetic energy. So when it comes to the change in kinetic energy, we're just talking about the kinetic energy, which is what? We're talking about the initial kinetic energy and the final kinetic energy. But how do we get to find that? So we know to say that our work is equals to the force multiplied by what? The distance. And we know to say our force is equals to what? The mass multiplied by what? The acceleration. So we know to say now our work is equals to what? Our mass times acceleration times what? Times the distance. So in this case, when you if you try to remember on kinematics, you have this formula. you have V final squared is equals to what? V initial squared plus what? 2AS. Alright, so it's like you have acceleration here and what? And distance. And that's the same thing that you have on what? On this side. Okay, so you can try to make the AS the subject of the formula and you see what you're going to get. So meaning our AS will be equals to our VF squared minus our VI squared. So remember to say we had a 2 here, so we divide by what? By 2 here. So we are going to bring this and replace here, because where there's AS, we replace with that. So we are going to say our work is equals to what? Our mass, we say open bracket, V final squared minus V initial squared divided by what? Divided by 2. We close like that. So when we try to distribute the M with what we have inside, our work will be equals to what? M V final squared divide by what? I'll say divide by 2 minus what? VM, try to make it a bit big. Say M V initial squared divide by what? Divide by 2. So meaning, if you look at this part or this part, it's still the same as what? The kinetic energy being equals to what? 1 over 2 mv squared. So that's what we meant by the change in what? In kinetic energy. Okay, so you should always keep it. There are some questions where you have been given to find the work that is done, and then they ask you to find the kinetic energy, and after finding the kinetic energy they want the velocity. So keep in mind to say the work done is equals to what? The change in kinetic energy. Okay, so when your initial kinetic energy is 0, so meaning your work done is equals to the what? The final kinetic energy, and you can just equate there. So this is the basic formula that we are looking for. This is the one that connects the what? The work and the energy. This is where we get to understand to say for us to do some work, there's energy that is involved, and we get to understand if, like, as we go deep into these formulas, this force is a component of what? Is a component of work. And when talking about this force, it has a component of what? Mass, as well as what? Acceleration. And when mass and when acceleration is involved, there's what? We know to say there's what? Motion. That is what? That should come in the what? In the picture. So for us to do that work, we need some force. For that force has to do with what? Acceleration. Because work, it has to do with us applying a force. Is like the product of the force and the direction in the what? In the force that is being applied. Yeah. So that's all from this video. Thank you.